In physics, we divide physical quantities into scalars and vectors. Scalars are the kind that only have magnitudes, so basically just positive values, positive numbers, and a unit associated with them. Whereas vectors have the magnitudes but also directions. So if you're driving somewhere, you would say, okay, I'm driving 25 miles east. 25 miles stands for the magnitude, east stands for the direction. There are various ways of expressing direction. So besides, north, south, east, west, you can say in the positive x direction, in the negative y direction, or give an angle with respect to a positive x-axis or negative z-axis or something like that. So there are various ways of expressing direction. Scalars can be added very simply, just like you're adding numbers. Vectors, though, have to be added in a special way. You can only add vectors that are pointed on the same axis, so they're in one dimension. Let's look at some notation first. So a magnitude looks like this. So the magnitude of vector A is vector A in absolute value. Then we have the whole vector A is A with an arrow on top of it. So if I have vector A and I have a vector B, and they're both in the positive x direction, then I can add them by a method called tip to tail, where I redraw vector A, and to the tip of A I bring the tail of B. So here is my vector A, here is my vector B. Then if I join the tail of A to the tip of B, I have vector A plus B. Now if I wanted to subtract them, so if I wanted A minus B, so here is A minus B, that's effectively saying that we're adding vector A, sorry, let's delete that. So we're adding vector A to the negative of vector B. Well, the negative of vector B would be B, but going in the opposite direction. And I made that a little bit too long. I'm going to shorten it just a bit. There we go. So we'll have to use the tip to tail method again. So what I will do is draw vector A, and to the tip of vector A, I'll draw the tail of vector B. So that means that A minus B will start at the tail of A and go in the direction of B. So this would be vector A minus B. Now if we had numbers, if we knew what the magnitude of vector A and B were, and then we solved for the vector, let's say that we get 3 units, but since it's pointing to the left, it would be negative 3 units for the vector A minus B. The magnitude of A minus B would just be 3 units, whereas the direction would be in the negative x direction, so the whole vector would be negative 3 units. Okay? Now, if we have vectors that are not in one dimension, not along the same axis, so let's say we have vector C going this way, and we have vector D going that way. And if we want to add them, then we can still use the tip to tail method. So that means that I'm going to redraw vector C, and to the tip of C I will bring the tail of D, so that when I add C to D, the resulting vector will be joining the tail of C to the tip of D. So this would be C plus D. Okay? Now, it is not very easy to figure out what this vector C plus D is. I mean, if we know the angle and if we know laws of sines and cosines, that's one thing. But there is a much simpler way of adding vectors that are not along in the same direction. So let's have an xy coordinate system here, and let's say we have vector A going this way. Let's also say that we know the angle that A is making with the x-axis. Then we can find the x and y components of A by drawing the projection of A onto the x-axis and onto the y-axis. So the projections will be AX and AY. And now we can use trigonometry. So let's say that we try cosine theta is adjacent over hypotenuse. So the adjacent to angle theta is AX. The hypotenuse is A. So that means that the AX, or the x component of vector A, will be A cosine theta. Now if I do sine theta, sine is opposite divided by the hypotenuse. So opposite would be the opposite of this angle here. So that's the opposite. And since this is a rectangle, we always have to make sure that when we draw the projections of a vector onto x and y axes, we get a nice rectangle. So this then is the same as AY. So the opposite of angle theta will be AY. So we have AY divided by the hypotenuse, which is still A. So that means that the y component is a sine theta. Okay, so this is how we break vector up into components. Now, if we want to add two vectors, so let's say that we have x and y, and let's say that we have a vector A in this direction and a vector B in that direction. We will project both vectors onto the x-axis. So this will be A sub x, this will be B sub x. And then we'll project both of them also onto the y-axis. So this will be A sub y, and that B sub y. So we can add vectors that go along the same axis. We can add AX and BX together, and we can add AY and BY, but we also have to pay attention to the direction of the arrows. So if I look in the x direction, I see that AX points towards the positive x-axis, whereas BX points towards the negative. So the resultant in the x direction is going to be AX minus BX, and the resultant, the sum, in the y direction is going to be AY plus BY, because they're both pointing in the positive y direction. Now, I didn't specify any angles. Let's do that now. So say that this angle is beta, and so that's the angle that vector B makes with the y-axis. Let's say that the angle that vector A makes with the x-axis is alpha. So then AX is A cosine alpha, and BX is, so first I have to put the negative sign here. BX, so let's look at that a little bit. BX is this vector. Well, that's also this vector. And if I look carefully here, I have the beta, angle beta, with respect to the y-axis. So BX is the opposite in this right triangle. Opposite goes with sine. So when I subtract BX, it's actually negative B times sine beta. In the y direction, so basically everything that was cosine before is going to be sine now. So I have A sine alpha, because A sub y is this quantity here, which is the opposite of angle alpha. So this and that are the same, and they're opposite of alpha. And then by, this vector is adjacent to beta, so that's going to be a cosine. And I'm adding them together, so I have B cosine beta. Okay, so now that I have the x and y components of vectors A and B, I can find the resultant r, and that is square root rx squared plus ry squared. And I can also find the angle that this vector is making with the x-axis, and that is inverse tangent of ry over rx. So if this is the opposite and this is the adjacent, tangent is opposite over adjacent. So we would solve for an angle that is with respect to the x-axis. So that's basically how you add vectors together. Now, if you want to multiply vectors, that gets a little bit more complicated. There are two ways of multiplying vectors. There is something that we call a dot product. So if we dot A into B, then A dot B is the absolute value of A, so the magnitude of A, times the magnitude of B, times the cosine of the angle between them. The other type of multiplication is the cross product. So A cross B is A, magnitude of A, times magnitude of B, times sine of the angle between them. Things are a little bit more complicated here because with a cross product, you actually have to use something called the right-hand rule to figure out what the direction of this vector A cross B is. So what I wrote here is really only the magnitude of A cross B. All right, well, that's about it for vectors.